wanted to bring you guys a little bit of science news out there. So I got this article from Ars Technica where they recently did a mimicking a impact on Earth's early atmosphere and with like an impact from an asteroid or meteor, whatever the fuck you want to call it. And it yields all 4 like amino acid bases. And so,
cool.
Hey, how about that? So let me talk about the article here. I'm going to do some sciencey talk real quick. So there aren't a lot of individual experiments that have ended up being staples of high school textbooks, but Stanley Miller and Harold Urey did one of them. They are the people who sealed up a mixture of gases meant to model the Earth's early atmosphere and jolted the gas with some sparks. What emerged was a complex mix of chemicals that included amino acids, the building blocks of proteins. It was a seminal experiment that gave researchers one of the first avenues to approach the origin of life experimentally, but its relevance to the actual origin of life has faded since the research had expired began to refine our ideas. Now, a French-Czech team of researchers decided to give it another look using a source of energy that Miller and Urey hadn't considered: the impact of a body arriving from space. The result? The production of all 4 of the bases found in RNA, a close chemical cousin to DNA and equally essential to life. So,
no. RNA passes through the cell wall and then it gets changed into DNA. It's a process. It's a thing, but it's still RNA becomes DNA.
RNA is they're the little worker machines that produce more DNA. They're the ones that, oh my God.
Yeah,
you guys need to like.
I think it goes through the Golgi apparatus and then it goes tick, and then it's DNA.
If you have not looked at like cellular biology, that shit is so fucking amazing.
It's pretty fucking rad.
Like you think like, just scratching your hand like I'm doing on the camera. You guys can't see on the podcast, but like thinking of hundreds of cells that are falling off when something like that happens, or, bacteria, viruses, whatever the hell else is on my gross fucking body. And you think about there's like hundreds of these things happening, and it's like each one of these is doing these little tiny fucking little things, little concepts and stuff going on inside of them. And it's just, oh man, it's amazing. Like cellular biology was one of my fucking jams in high school. I love that shit so much.
Part of the reason I love cheese. Cheese is alive. I mean, it's not like a living thing, but it is alive. Like it's not an animal, it's not a plant, but it's got active work going on in it. It's alive.
That's why I like beer, because it's like
also alive.
It's the excrement of yeast that make this delicious fucking beer.
It's not the excrement, you know that. It's more akin to exhalation.
I'm being funny. I want to keep all the delicious beer to myself. I don't want to share it with the world. So anyway, there are 2 reasons that the Miller-Urey experiment gradually fell out of favor. The first is conceptual. At the time, people focused on life's dizzying web of chemical reactions, almost all of which are catalyzed by proteins. So it was hard to envision life without proteins. The formation of amino acids could enable the formation of proteins, and thus seemed to provide an obvious route to a primitive biochemistry. Genetic material could be added later. What Miller and Urey didn't know, and what we wouldn't find out for decades, is that proteins don't have a monopoly on cells' catalytic chemistry. We have found that in a number of key reactions in the cell can be catalyzed by RNA. Both RNA and DNA have since been shown to be able to participate in all sorts of interesting chemistry. Those discoveries helped usher in the RNA world hypothesis, which posited that biochemistry and genetics got their start simultaneously in the form of catalytic RNA molecules. That's getting a bit thick here. Amino acids might be useful cofactors to RNA, byproducts of the reaction. God damn it. Sorry, guys. I know it's getting thick. But they weren't central to the start of life. There's the part right there. The challenge wasn't showing how amino acids could form under simple reaction conditions. Instead, the focus shifted away from their research onto ways of forming the chemical bases that are the building blocks of RNA, which are the amino acids. So in addition to conceptual problems, the original experiment ran into practical ones. What these 2 guys assumed what they're calling a reducing atmosphere, unlike today's oxidizing one. In practical terms, this means that nothing akin to what is Saturn's moon Titan, where the major components of our atmosphere are linked to hydrogen atoms, so ammonia instead of molecular nitrogen, blah, 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 blah. Anyway, I know it's boring as shit. So
Yeah, sorry, X, that got a little bit heavy there.
it got really
I mean,
heavy.
It would be
It's fascinating to me. But
no, it's fucking fascinating. It's a fascinating topic.
But it's dry. It's so dry.
The way you were reading it was pretty dry. I feel like if we were reading it ourselves, we would have been like, "Oh, neat," but like you were just rambling really fast, and it was just like, "Okay, you're throwing a lot at me right now."
Trying to get it all in there. Just get it all in there, balls deep. So anyway, so the reason that they revisited the whole Miller and Urey thing is that the people
this better be good because I'm so unsatisfied right now.
Last paragraph. The people behind the research argue that the current evidence suggests that more than 3.6 billion years ago, the atmosphere was a bit on the reducing side of neutral. In any case, it's clear that the early Earth was being hit regularly by things like comets, meteors, asteroids, whatever you want to call them, which carry a large payload of reduced chemicals. So while their atmosphere that they did in their original experiment wasn't the one that dominated it, they argued that it would have been relevant. So they're saying they wanted to redo it, but they wanted to look for the presence of a different chemical like formaldehyde or formamide. Sorry, what the fuck. Anyway, so it's amazing that they did this experiment and they did it using pretending to have a asteroid strike, and they managed to produce all 4 of the amino acids that show up. And so I just
too long didn't read. Oh, it turns out that the amino acids can be formed in a big boom, and then the things that are protein can attach to organic materials, and then life might have happened.
Yeah, so that's another God of the Gaps going, oh look, here's another little whoop, let's just put that in there. Like
it can happen by accident. It can happen by accident.
It can happen. Giant fucking meteors causing life. Not just destroying life, but creating it. Shit's amazing.